Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of comparing monetary incentives. This is standard 7.13F in the great state of Texas, and we are using item number 12 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got Leo, and he wants to buy some shoes. He finds shoes at 3 different stores. They're each priced at $35. But here's the thing. They're each having a sale. And you notice that they've kind of labeled their sale differently. So we've got store X, store Y, and store Z. This is a good skill to have to know what the actual price is, because store X, 15% off. Store Y, $5 off. So you notice X is using percentages, Y is using dollars. Which one's a better deal? Because they're all starting at $35. The question is which one's got the best deal. And then store Z is giving you a fraction. That's kind of tough. Really going to make you do math. All right. So which statement about these shoes is true? And we're looking for the sales price. Which one's got the best sales price and which sales price is actually correct? Well, let's just do some math. We're all starting at $35. So store X is 15% off. So we've got 2 different options here. So we could multiply this 35 times our 15%, which is going to be 0.15. That's going to get the percentage off, right? And then we have to subtract all of that from our original price of $35. Is 2 steps. If we multiply by 15%, we're just going to get the amount off. We need to know what the full price is. Or we could say, well, 100%, take away your 15%, that's going to give you 85%. So if you've got 15% off, you really just have an 85% of the actual price, and that gives you 1 step. So that's what I'm going to do. I'm going to multiply my 35 original price by the 85% that is actually still remaining, and I don't have to do that subtraction at the end. So that's going to be 25, 15, that's 17, that is 40, 24, 28. All right, so we've got 29.75, 2 digits behind the decimal in the factors, 2 digits behind the decimal in the product. So it looks like my sales price here, I'm going to put that right here, is $29.75. That's decent. A little bit more than $5 off. So store Y, $5 off. Well, look, that's going to get you the same thing, right? Is 35 minus 5. This is pretty easy. That's going to get you $30 sale price. All right. So we've got 2 different sale prices. Obviously, store Y is the easiest one to calculate. Doesn't mean it's the best one. As you can see, store X is a little bit better. 25 cents better, but it's still better. And now we need store Z. Well, we could do the same thing here. If we've got 1/5 off, right here, let me draw 1/5. If I take this 1/5 off, that would, and multiply that by my 35, that's just going to tell me how much is off. Then I need to subtract that from the full 35. So what it would be better for me to do is actually multiply my 35 times whatever's left over. What's left over is 4/5. So I'm only being charged 4/5 of the sales price. So 2 different ways we can do that. We can multiply 35 times 4, divide by 5, or we can just realize, you know what, this is 4/5. That equals 0.8, 8/10. We should know that. And so let's just multiply that. So that's going to be 40, 24, 28. I've got 1 digit behind the decimal here. So I need 1 digit behind the decimal here. Just to make it look a little bit better, I'll go ahead and put 2 digits. But we've got $28. So that fraction looks like that is going to be our best. Best sales price means the lowest. And so we here are going to go with G, $28.